Welcome to day 18. So today we are going to look at logging. So I'm going to do this in two steps. We need a library to log, but I also then want to focus on making this logging optional because let's be honest, have you seen a grep or grep like with logging? We don't really need logging for grep, but I needed it because I wanted to debug when I walk the directory, when I looking at files. I wanted some kind of logging to make it easier for my own use, right? So first, we need a logging library, and Sabra has this great blog post on comparing the various options available in Common Lisp. So there's a bunch of libraries, and there is a nice table comparing the different libraries with features like the log levels and whether you can do different things and so on and so forth, right? So I did try a few different ones. I wanted very simple logging. Like I said, this is not an application that requires continuous logging. So after trying a bunch, I went with warm. Basically, it's the simplest, like the blog says, it's small and simple, and it's very straightforward to set up. So in my code, if you go and see where I've added logging, it's very simple. We have added warm to our depends, and then this is our core logging functionality organized into a separate log.lisp, still in the same package, still in the clgrep package. So there is a setup function we do once. So we just call this in our code in the main function. And here we are just setting the log level to be info, something very simple. And we're also setting the output location for the logs, right? So we are saying open a file clgrep.log direction output and overwrite and create the file if it doesn't exist. And basically we want to rewrite logs directly into a file so that I can use that for debug. And now to actually use the log, I have this small macro. For now, just think of it, it can be a function. It can just be a function which is running warm info, because I don't really care about log levels here. I don't really want debug versus log versus warn and so on. So I'm just going to use info every time. So I just have a wrapper to log this easily. I'm going to pass the arguments in and just log things. So here we see some examples. I've just printed out when I was visiting files and I was skipping a file and so on. And this is what we are doing here. To see this in action, let's just go to my folder here, and I have this file like you see, and it just as simple things. So it's just saying that it's visiting a particular directory inside that, file inside that, and so on. If you see here, there might even be some entries about skipping, depending on if something exists. I don't know if there you go. It's skipping webm file because that's a video. So I could use this to just debug. So this is absolutely basic logging setup. Now I could have just used a function to do this instead of a macro. So let me explain a little bit about why using a macro kind of makes sense here, because my aim is to disable logging. Like sometimes I just don't want logging, so I want to quickly toggle it with a variable. Let's see. Now, to understand this, I have some dummy code I've written here, which we'll be looking at. So let's say we have this variable log on, and we are setting it to true, right? So in the starting, we want logging to be there, right? Now, focus on the simple log function. How would we do it? So this is just a function which is taking its arguments, and we're just going to print for now. So if the variable is true, we are going to apply this function format true and the rest of the arguments. And for a use example, let's see. So I'll just compile this, and if you see here, we have the actual function where we're using this logging. So we're going to log f something, do something, then log f again, right? So I can again compile this, and just to keep things on a equal basis, I'm going to also make this log f function inline, right? So that it's not a function call, but it's just going to inline code inside. So what this means is, if I just call the function, we have our primitive logging kind of thing working. And that's working because my variable here is set to true. So if I make this nil and recompile this, and now rerun this function. This time it works the way we want. It's not basically logging because we've switched off logging. That's great, right? But if I disassemble this function, you will see what this function is actually compiling to, and that's like around 196 bytes of code. There's a bunch of things here. You see that it's referring to the log on variable, it's printing the string and all of this. So all of the code for this my function with the logf portion inlined is this big 196 bytes. But my aim with the grep, and because I mentioned I do not want logging, I also was concerned about performance, right? Maybe this is a premature optimization. That's very much possible. I think it's true, but because I don't want logging, I also don't want the overhead of logging. So I'm not going to change this variable like later. I'm going to set it in the beginning to true or false, and the rest of the run of that grep, I don't want logging, right? So in this, so the point is this function, this function version of doing this means this extra if condition check will always happen irrespective of what the variable is, right? And that's exactly what we don't want. I don't want these extra instructions to happen. I just don't want logging. I want to just remove the code, and that's where macros can really shine. So let's look at the macro version. So I'm going to compile the macro, and I'm going to also switch our function to use a macro version, right? And now because our set is set to nil, I can go in and I can run this thing, and I'm not getting any logging. And the idea is when this runs, the macro will expand. So this line is not a function call, it's a macro call, and a macro call will happen at compile time. So when I did this control C, this is when compilation happens, and at that point, this, because logm is a macro, this logm macro is going to run. And what does logm macro do? So let's look at the code. It looks very simple, right? It looks very similar. So inside this, I'm checking if log on variable. So this is like exactly the same like we had in the function version. But after that, I am now returning data. So I am going to return this. When I quote, you gotta put this single quote. It's similar, but I'm using double backtick because I'm going to use this comma here. I'll talk about that in a moment. But the point is, this is basically a string. So this is not code. This is returning a string or returning an expression, which is code, which will be run later at runtime. So when this login runs, which happens at compile time, this if logon runs at compile time, and then this portion is simply returned, which is what this macro expands to. So this macro expands to this line, which is the format. And like if I just open this again, and if I set our variable to true, right, and I recompile this, so it's not set to true, but if I run the function, I am not going to get any logging because I didn't recompile my function. I compiled my function exactly once, and when it compiled, that time this logon variable was set to false. So if I want to see the updated version, I should recompile my function, and once I recompile my function and run it again, this time you will see the log being printed. And obviously it works in reverse, right? So if I go here and I switch off my variable, so if I switch off logging, it is not going to reflect. If you run this, it's not going to reflect. It's still having logging because we didn't recompile. So let's go back here and recompile the function, and if I run the function now, we have the updated thing. And now what is the advantage of this? So if I disassemble this version of the function, you will see 16 bytes. So earlier we had 196 bytes for the version with the if condition and the string comparison and so on. But now look, we don't have any of that because it just simply writes out the string. The string is just not even there in the compiled function because it's not needed. This is the power of macros. So this is where we are getting the full benefit of common Lisp macros. We are running the logm macro at compile time, not at runtime. So now that we have seen the benefit of using a macro here, let's see how to actually use it, right? Because we don't have a package where somebody can set the variable and then continue with our code, we have an executable. So the program is going to start, and at that point, it's already compiled. So I need to set this variable at compile time. So the simple way to do it is I can go to my makefile, and because our actual build is happening here at asdf make grep, I can add a statement before this to set that variable. So that is one way to do this, because then that's just before you actually compiling the rest of the code. Now, that's not that clean. So the next, I mean, the better option here, which is what I've done here, is to actually use a build time feature. So if you see my grep.asd file, you will see this some kind of code here. So let me talk about that a little bit. So the idea is there is this variable called features, and normally this is used to manage, so you can see the current value, right? So basically things like swank, quick lisp, asdf 3.3, these are all indicators of my current common lisp setup, because there are multiple implementations of common lisp. This is a sbcl. People have other compilers like ccl and things like that. Now you don't really know the rest of the code of what features are actually available, and this is true for things like operating system or other specific features. So this is what it's actually used for in the core, but we are doing something different. We are going to use that same mechanism to enable or disable logging as a feature at a compile time. So the point is, this line is just pushing in this keyword into this list, right? So if we comment this out, this will no longer be there as a feature. If this line exists before the system definition, the features is going to have logging as a entry. Now, what does that mean? That means two things. So one, that means that in my def system definition, I can use that as an conditional package import. So look at this line. So what we're saying is libraries like UIOP, file system utils, path name utils, lparallel, broad threads are always going to be dependent on, always going to be imported. But my library warm, the logging library, is dependent on this feature logging being present. So if my logging feature is not there, it is not even going to try to import worm. So it doesn't even need worm to be installed. So just think about that, the implications of that. So you can use this to actually sort of strip out libraries that you don't need if you don't actually have code that depends on this. Now this is one aspect, right? This is the third party library, but what about my own code? So if you come back to the log file, you will see here I have changed my code. It looks a bit different, and that's what this ash plus feature name is about. So normally you might see in other places people doing ash plus sbcl and so on to have implementation specific code. So maybe their code is different for different common lisp compilers. In my case, what we are saying is, if the logging feature is present, then this function should exist, right? And you see here that ash minus logging. So if the logging feature is not present, instead this expression is going to be compiled. So if you see here one of these two, so this line 6, the expression on line 6 or the expression on line 12, only one of these is going to get compiled, and depending on the feature is available or not. So if it's not available, it's just going to, the function is going to nil out. So I can always call log setup in my main, but it will not do anything. And we have the same logic here when we define the LO macro. So I have done the same thing here. I have done ash plus logging, and that is a version which has the macro, and ash minus logging, that's the version which is just going to 0 to nil. Now I could have moved this line outside, then I would have to repeat this def macro line twice like we did here. So this is just a simplification of moving this inside. So these are like two variants to do things. But now the same thing we saw earlier, except at compile time, we are going to decide whether we have logging or not. So let me show that to you in action. So I'm going to remove the clgrep.log. I'm going to make our file. Okay, we added some extra code which I should remove. So let's go back and now logging. I'm going to delete all of this. And that was just for the demo. So now this compiles, and because logging is a feature, if I do clgrep something, you will see the log file has been created, and I can see that it has contents. It is grepping all of this, right? Now I'm going to remove that log file. I'm going to go back here to our grep.asc system definition. I am going to comment this out, right? So if I comment this out and I make our system again, you see there is no log file here. I'm going to do the same grep again, and this time you see there is no log file. There is still no log file. So the log file was not created because that code is not, it is never going to execute log setup, or it's going to, or the individual log lines are going to out to nil. Even better, it's not even going to import worm, and it's not even going to compile it as a part of the full system. So in this video, we have seen what logging we are doing. It's very simple. So really the video is not really about logging. We also seen how you can make this kind of things optional, first by using macros, but then make it even better by doing things at compile time.